Okay, now let's talk about advanced UFunc features. So many Numpy users make use of UFuncs without ever learning their full set of features. We'll outline a few specialized features of UFuncs here. The number one is specifying output. So for large calculations, it is sometimes useful to be able to specify the array where the result of the calculation will be stored. Rather than creating a temporary array, you can use this to write computation results directly to the memory location where you would like them to be. For all ufuncs, you can do this using the out argument of the function, starting here. X is equals to np dot range 5, y is equals to np dot empty 5, np dot multiply x out equals to y. Print y. This will result in 0, 10, 20, 30, and 40. This can even be used with array views. For example, we can write the results of a computation to every other element of a specified array. Y is equals to np dot zeros np dot out is equals to y, the square bracket, double colon 2, print y. This results in 1, 1 point, 0 point, 2 point, and it goes on. So if we had instead written y in square bracket double colon 2 is equals to 2 double steric x, which is this would have been resulted in the creation of a temporary array to hold the results of 2 steric double steric x, followed by a second operation copying those values into the y array. This doesn't make much of a difference for such a small computation, but for very large arrays, the memory savings from careful use of the out argument can be significant. Now let's discuss about aggregates. So for binary ufuncs, there are some interesting aggregates that can be computed directly from the object. For example, if you would like to reduce an array with a particular operation, we can use the reduce method of any ufunc. Quoting the example here, a reduce repeatedly applies a given operation to the elements of an array until only a single result remains. So for example, calling reduce on the add ufunc returns the sum of all elements in the array. Let's do this. X is equals to np dot range 1 np dot this will result in 15. So similarly, calling reduce on the multiply ufunc results in the product of all array elements. np dot multiply dot reduce. This will result in 120. So if you would like to store all the intermediate results of the computation, we can instead use accumulate np dot add dot this results in array 1, 3, 6, 10, 15, and d type int 32. So now let's do that. Write another code np dot multiply dot accumulate. This results in 1, 2, 6, 24, 120, and it goes on. So note that these particular cases, there are dedicated numpy functions to compute the results. Now let's discuss outer products. So finally, any UFunc can compute the output of all pairs of two different inputs using the outer method. This allows you in one line to do things like create a multiplication table. Now let's start. X is equals to np dot arrange 1 till 6 np dot, we'll continue here, np dot multiply dot outer x. This will create a table. So the ufunc.at and ufunc.reduceAt methods, which we'll explore in the fancy indexing, are really helpful to use. So another extremely useful feature of ufuncs is the ability to operate between arrays of different sizes and shapes. A set of operations known as broadcasting. This subject is important enough that we will devote a whole section. Computation on arrays broadcasting. Right. So, learning more about UFuncs. More information on universal functions, including the full list of available functions, can be found on the Numpy and SciPy documentation websites. So if you recall that, you can also access information directly from within the IPython by importing the packages and using IPython's tab completion and help functionality as described very earlier in help and documentation in IPython.